Hi everybody, good morning and welcome to Barcelona, to MWC. This is theCUBE's live coverage. My name is Dave Vellante and I'm here with John Furrier and the whole CUBE crew. This is day 3 of our wall-to-wall coverage, our 5th year here at MWC. It used to be called Mobile World Congress, but it's expanded much beyond telco. I mean, telco's still the core, but beyond telco, beyond mobile, really into AI, and also, really for the first year, we're hearing a lot more about quantum. And I'm really excited to have Mark Hughes here. He's the Global Managing Partner for Cybersecurity Services at IBM. Mark, good to see you, welcome.
Good to see you, Dave, thank you for having me.
So you're very welcome. So we walk into Hall 2, and boom, there's the IBM booth, and you have this gorgeous, golden chandelier, and it's a quantum chandelier.
Indeed.
Right? It's actually a lot of the cooling of that quantum chandelier, right?
Exactly, I mean, in fact, it's just a little chipset at the bottom, which is where the magic happens. The rest of it is the infrastructure that you need with the cooling around it.
Yeah, so we're going to go over there a little later on, and we'll do a hit right there, so we'll post that so you guys can see it. But so I hosted with Luke Niazzi a roundtable with a number of executives on Monday, about 23 executives, from all over the globe, a very senior level audience. And we were talking about sort of the intersection between AI and quantum and hybrid and sovereign. So I want to set that up. What is the sort of thinking around quantum? What should executives know about quantum, the sequence of when it's coming? Where should they be focused right now? Because they're drowning in AI, but quantum looms, and you guys are making some great progress there. What should they know?
Well, what they should know firstly is that quantum's going to revolutionize computing as we know it today, in the same way, to a certain extent, how GPU computing has really changed the face of CPU computing over the last couple of years. So we see really in IBM a spectrum of computing emerging, where we have traditional CPU compute, which is going to be there for a long time yet, and has unbelievable utility and is extremely useful. GPU compute, which we see now emerging, which obviously is really powering the AI revolution. And then now we enter with quantum computing. And quantum computing is all about basically how compute is now going to work not in a binary way, but in a way in which we embrace quantum mechanics to be able to compute in multiple dimensions at once, if that makes sense.
Yeah, it's not just 1 or 0, it is
there
both,
we go.
Right? Okay, and that's kind of twists people's minds.
Exactly, and it started to twist my mind, but it absolutely opens up incredible opportunities, but that is within that spectrum of compute. So one of the things that we're really focused on in IBM is that opens up a lot of possibilities for organizations in things like just straight algorithmic computing is going to be revolutionized by the power that quantum computing will be able to give. So solving those complex algorithms, for example, but also doing much more complex search, which is something that actually traditional computing, GPU and CPU isn't that good at. So quantum's going to be amazing at that. And then one of the other key areas that we see emerging is about mimicking life sciences. So really now the application of being able to mimic nature and what quantum really unlocks for us to be able to do that. So it's going to be very, very good at broad categories that I've sort of outlined, but that works in conjunction with GPU and CPU compute, so we create that spectrum of computing. So 2 real things, Dave. One is the quantum compute capability itself, and then secondly, at IBM, we're thinking hard about how we're going to be able to enable organizations to embrace that within that spectrum of compute and orchestrate their workloads into whichever bit of compute is relevant for them.
I think the other thing the audience should know is we talk about all the power and energy needed to run these AI factories, and that's really one of the big constraints now to develop all these tokens and the intelligence. Quantum doesn't take a lot of energy, right?
Not in the same way. So that is one of the big advantages when you compare it to some of the GPU computing as well. So that's a key consideration. Still, we need to have areas, data centers obviously where we have that quantum compute capability to enable organizations to have access to it. Lots of considerations around latency and the like will be very prevalent as quantum comes online. And really where we are now in our genesis of that, we see quantum really utility. There's some early adoption now, but really around 29-30 is when we see real mainstream capability being able to be available and used in those areas that I talked about, and perhaps many other areas that we haven't thought about yet.
So all my friends in the crypto world, and all my friends who don't own crypto say to me, wait till quantum computing comes out, you're going to lose all that crypto. So people are fearful of quantum.
Yeah.
So you hear this term like quantum safe and quantum readiness. So what is that? What's the truth about quantum and what it is capable of doing and how organizations can protect themselves against attackers?
Well, it's a great question, Dave. So look, within quantum computing, as I said earlier, there is this area where we're going to be able to solve complex algorithms in a way in which traditional computing can do, but it takes a very long time. Months, if not years, to solve for. And the specific area is around the factoring that goes into cryptography that we use today, all day, every day. So, of course, the security team come up with one of the downside use cases of quantum straight off. And what that is that compute capability is now going to be able to solve a thing called Shor's algorithm. And what that means is it's going to render asymmetric encryption vulnerable. So in other words, at the moment, our asymmetric encryption that we use, PKI and the like, it's extremely difficult for traditional computing to solve and essentially decrypt. It takes literally months, if not years, for that to happen. With the advent of quantum computing, one of the use cases in there is that the algorithm that can resolve, essentially break, if you want, the crypt that we use today, the asymmetric crypt that we use today, will be able to be executed, and therefore the asymmetric cryptography that we use today will become vulnerable. So it's really less about quantum per se, it's more about cryptography and the fact that now quantum is going to give us the ability to break asymmetric encryption.
So that really is the catalyst for executives to start thinking about quantum.
Yeah.
So what should we do to, let's assume it's coming. Let's assume it's coming next year, right?
Yeah.
Which we know it's coming eventually and it'll be in production. You guys are going to show, I think 2026 is really a milestone year for IBM. But if I'm an executive, say, okay, I want to prepare for this. What can I do today, like right now?
So, as I said before, the big thing is this is a cryptography challenge. Now, we all know cryptography, we used it for years in every way, in everything that we do. So the first thing to do is to establish, as an executive, what cryptography do you have running in your organization? And so the initial phase, fairly straightforward, is just straight discovery exercise. So what cryptography is there in that organization to start with? So going through the estate, the environment, the IT environment that you're operating in, what crypt do you have running, where is it, and is it embedded in hardware, is it software driven? Those are key questions, so there's a discovery exercise. Now here at IBM, we've actually built some tools to help organizations do that. So there is a software tool that we've built which actually allows organizations to run that environment to discover what crypt they have in their environment. Now this is something which every organization has lots of cryptography out there, but really understanding what it is and where it is not necessarily being as high a priority as it's going to need to become. Because what happens then, having discovered what crypt is available, then really the next step is, well, how vulnerable am I going to be now if that crypt is now vulnerable, in the way in which I described with the advent of quantum computing. Now we see that consideration around the time, around 2029, 2030 is when the quantum compute capability is going to exist to be able to decrypt and run, as I said before, Shor's algorithm. So that second phase is, well, knowing that now, what do I need to do as an executive, understanding where my crypt is, what action do I need to take? How do I now prepare? And there are a number of things that organizations can do. The first thing is, we at IBM have developed 4 quantum-resistant algorithms, and they are now available. And so there is the opportunity to replace some of that cryptography with now cryptography that is quantum-resistant, which is a good step. But not everything is going to necessarily need that from the get-go. There's some considerations around, for example, hardware. Can that cryptography be run in the same way that traditional cryptography is being run? The strings are longer, for example. So there are a number of considerations that need to happen in that second phase about the strategy and the approach to cryptography migration that needs to be taken in the organization. So relatively straightforward in the sense of discovery, then adopt and understand what the strategy and the approach should be, and then really the third phase is then how to implement and make the changes necessary. Implement the quantum-resistant cryptography, work out where there may be existing cryptography that you want to encapsulate, for example. So there are different approaches that we can do, and we can work with our clients to help them get right.
So Mark, a lot of the encryption is kind of invisible to me because it's in, like you said, in my hardware, maybe down to the storage device or the silicon. And you've got the discovery, the tooling, you've got these 4 quantum resistant algorithms.
Yep. How
do I apply those deep into the stack? Do you work with partners to do that, or do I create a shell around it? Explain how, as an executive, a technology executive, I can protect myself with those sort of hidden encryption.
Yeah, it's a great question. So firstly, we do work very extensively with partners. Obviously there's a lot of crypt providers around, and so we work very closely with them to help them understand. And they have access now to those post-quantum resistant algorithms as well that we've developed here at IBM. So it all really comes back to that, well, what is that crypt doing? So it's understanding the context within which that crypt is running in your organization. And that will determine what you actually do. So in some cases it will be, let's take a quantum resistant algorithm and replace that. So that will be one area. As you said before, there is the opportunity to encapsulate existing cryptography to allow a service to run, because there's got to be a handshake, obviously, when we have public keys and the like, in the whole crypt ecosystem, if you want. And really to then encapsulate that so we can perhaps continue to run existing crypt within a quantum resistant shell. So that's another approach that can be taken. And then, the other thing is, of course, working with partners is to say, look, you need to address this because, your crypt is going to become vulnerable, so you need to do that, and therefore, in some cases, we see organizations where their partners need to really take the lead to ensure that they address it at the outset, where perhaps that organization is a consumer of that cryptography.
So let's assume we've plugged that threat.
Yeah.
Is there another dimension, I'm sure there is, of quantum that can now protect me against attackers?
Yeah.
Can you explain that angle?
So that's really where we see the application of quantum computing in the security space, like we're seeing, for example, the application of AI in the security space. So in security overall, we've been pretty good over the years, because the challenge in computing in cybersecurity is how do you take vast amounts of signals and work out and detect where there is something that looks wrong going on. And so the machine learning that we've built over many years to enable that to happen, now we're really embracing AI to really now use that to really speed up and become more accurate in cybersecurity. And of course, quantum now brings yet another advent of our ability to be able to detect at speed and deliver accuracy that we haven't been able to do, and we will be able to do now when that advent comes. That compute power is going to give us the ability to solve those complex algorithms that we often see in cybersecurity that we'll be able to now apply and help us defend better. Now, of course, that also has the other impact that just straightforwardly, with that broadening spectrum of compute, the attack surface is going to increase. Now we're coming up to RSA, Dave, and that's the big cybersecurity conference in San Francisco in a few weeks, and I really do feel that that's going to be a big topic of conversation beyond that crypt conversation as well, which is how do we not just embrace AI, but how do we ready ourselves for how that attack surface is going to expand as we see the advent of quantum computing as well.
Okay, so we've got you got to shore up Shor's algorithm threats, okay? And then you can then protect yourself using quantum against the attackers. AI is ubiquitous.
Yeah.
In fact, the attackers probably have better access or as good access to AI as the defenders, and they're probably as effective and capable of using AI. Will quantum be similar or different in that? Will it be harder for the attackers to get access to that quantum technology, or do you expect that it will be as ubiquitous as AI is?
No, I think it's going to take time, right? So at the moment, we see only very early use cases, very early adoption of some exploratory work with quantum. I think quantum's there's some time yet before it becomes mainstream. Obviously, in the context of quantum safe, as I was saying, it's a pretty binary thing. Once Shor's algorithm can be executed, well, in theory, therefore, crypt is vulnerable, so it's a sort of binary thing. Large-scale adoption of quantum will come over time, and the ability for everyone, including threat actors, to use that capability, I think is going to emerge over time. But let's not forget, quantum is on that spectrum of compute, and just the way in which threat actors use and power their ability with AI-driven capability and with traditional compute capability, yes, I can see certainly that they'll be embracing that as it becomes more mainstream and available.
Because essentially it will be quantum as a service that anybody can have access to, right?
Exactly,
yeah.
we see that happening in the future because it will power so many new things that we'll be able to do, which we're currently not able to do at the moment. That said, quantum won't be brilliant at everything. Quantum is there's a very big space for traditional and GPU compute that will continue to exist for some time yet.
Well, I think you made that point early on, and that's an important point to stress, is we have classical von Neumann computing and traditional CPUs. We have now extreme parallel processing with GPUs. Quantum sits beside those and opens up new applications and new use cases. Okay, you brought up RSA, I want to talk about AI a little bit. Ironically, our John Olsik wrote a post, a preview to RSA, and I said, ironically, the theme of RSA this year is collaboration.
Yeah.
And yet, one of the main topics is going to be agents, machines, humans collaborating, but it's really going to be agents talking to each other.
Yeah.
So that brings new threats.
It does.
Give us your point of view on the multi-agent threat, what protecting AI means from IBM's perspective.
Well, I want to start actually with the other way around, because we think about it this in how do we embrace AI to protect ourselves. So, of course, in cybersecurity, and in IBM, we've been right at the forefront of being able to embrace and embed and build agentic AI into our security services, which is what we have now. And of course, that ability to be able to now run and leverage and use AI to defend better gives us that insight to understand how we can apply and how AI is being applied more broadly. Now, with that comes a lot of the considerations that we know. How have we thought about governance? Where does trust, and how do we trust the AI and the language models that we've built, and how do we have trust, and essentially apply zero trust principles to how now the agents work as well. So we've done a lot of that thinking, and the reality is, what really is important when thinking about a trustworthy approach to AI, and at IBM that's what we're really all about, is how do we establish and create trust in all of those great services, is how do you start with understanding how you're deploying your AI into the enterprise, into the organization. And what I see many organizations perhaps struggling with is they have to think about how they're applying AI into the organization in a systematic way, and not in a piecemeal, let's just do some early adoption over here and early adoption over there, without the ability to then grasp the enormity of what the AI is going to offer for an organization. Marshal that in a coordinated way across the organization. We're seeing a lot of early stage adoption, a lot of experimentation, not necessarily seeing the benefits that we thought we'd see. And I think a lot of that is because we're not thinking about that comprehensively enough. Now with that, Dave, coming to your question, then comes, well, what are the security considerations we need to put around that? And that is something that I see many organizations not having thought about well enough yet. And the core thing around that is what data is being used. And actually we know that pretty well. We've been working with data security for many years. So what is the underlying data that is being ingested into the models? A lot of the enterprise use cases are based on small language models, which aren't general purpose AI, small language models that are built. So where's the data coming from? How's that being ingested? What's the security around that? Now that's something we understand pretty well and we can do, but it needs to be thought of carefully. Then you have your agents that are running across that, and of course, then comes that absolutely key question, which is, it's the whole point of agents, they have agency, right? So with that agency, how do you ensure that you have the right consideration around what levels of access they have, and what levels of authority that they have to be able to then call on other agents, beyond the way in which we just make a simple API call, that becomes now much more sophisticated. But it's containable in the sense that you know what models you've got, you know what agents you're building, you want them to perform various tasks, you can then have, and we developed this concept of IBM of a reflective agent that essentially is there and built to observe, to ensure that that agent is working within the parameters that it is expected to work. And so really that's our approach, which is to say we have our AI, our agentic AI that we've built, but we then have a series of reflective agents that look for, in a runtime context, what's actually going on and are they performing in the way in which we'd expect them to, and are they operating with the level of authority that they should be or not. So it's not a human identity, it's not a sort of service account, if we think about it in that way, it's a new concept of identity which we now are really embracing, where we use AI itself to ensure that we can control the level of access that those agents have.
So there's a couple of threads I want to pull on there, because humans have been the weak link in terms of cyber defense. And Nir Zook from Palo Alto, founder of Palo Alto Networks, a couple of RSAs ago, I think put it really well. It was profound in my view. He said, look, AI changes everything. That previously, we could stop 99% of the attacks, that 1% was left to the humans, and the humans could do their best to keep up, and generally did a pretty good job. AI wipes that away, because the humans can't now keep up with the machines to protect that 1%. So you need intelligence, machine intelligence, to defend. Okay, so with that as the premise, and sort of the do-over in cybersecurity, the second mega trend, and this is something that Akesh Narora categorized, he coined the term platformization. Tools consolidation. Now when you talk to practitioners, they struggle. And you sort of touched on this before, all the complexity that they have, it's just another shiny new tool. So we're starting to see a little bit of evidence that those tools can be consolidated, but then something comes along, like MCP and multiple agents, so some new tool comes out. So do you see that agents will allow you to reduce that complexity? And so that humans can focus on the strategy and kind of cleaning up that complexity as opposed to fighting fires?
Yeah, it's a great question, and yes is the answer, right? Absolutely it is. There are now those key platforms emerging. Palo Alto is one of them. We see others in the market as well. At IBM, we work extremely closely with Palo Alto, and we are really seeing now less focus on the tools, which has often been the case. Let's think about it. We recently talked to over 1,000 of our clients, and on average, they're running 80 tools from 34 different vendors. I mean, that complexity, just when you're in a world where you have to speed up and become more accurate, because as you said before, the attackers now have the AI and they're using it to speed up themselves. That complexity just drives slowness and slowness of response, which is just not an option now. So absolutely we're seeing a less emphasis on specific tools, much more emphasis on buying into a platform approach, which allows you to be speedier, but also how agents now, the AI agents that we're building, which are highly context aware, can not just use those tools, but use other sources as well to now really give much more context to allow now those platformized tools to actually do a better job of what they are needing, and we've always needed them to do. So I think it's a combination of platformization on consolidation in the security space, and you see, for example, Palo Alto is just recently in the process of acquiring CyberArk, and we've seen other consolidations happening as well. Palo Alto has also recently announced that they're acquiring Cloudsphere as well. So some really interesting consolidations and almost growth of that platform approach to encompass many different areas. So that's one part of it, which we see a massive trend around that, but also then how do you deploy the agents across that? Because what we need is we have lots of different agents appearing in lots of these different solutions, but what we find at IBM with our clients is how do you orchestrate all those different things, because obviously it's not a one size fits all, rip and replace. There's a transition period to get there, and also agents with that context-aware approach that they have, how do you orchestrate those agents in the context of the risk that is in that particular organization? So I think it's both platformization, agents being deployed with that orchestration layer that's really going to supercharge cybersecurity in the coming months, really.
And that's really IBM's real deep value add is the how. The how you apply this, what the timeline is, how you do it without breaking the bank, getting from point A to point B, what is possible, and then how to get there. All right, last question. We mentioned RSA, we talked about it a little bit. What are we going to see there from IBM? Set it up, give us a plug.
Oh, it's going to be amazing. So that orchestration piece, last year we talked about our autonomous threat operations machine, which is really where in the SOC environment, we launched a load of agents that were working agentically, and I have to say the response, Dave, was astonishing. Everyone looked at it and went, really? Everyone else is talking about this, IBM, you're doing it. And we are, and we've now deployed that to over 200 of our clients, and we see some unbelievable outcomes there in terms of some of the traditional security operations space, really revolutionary, much faster, much more accurate, using those agents. When you think about how the sort of human interaction used to be in the past, that's really done some great stuff. But now we take it to the next level. Now we talk about how do we now look at a much broader view of security, and how do we take agents that are now very context aware, and not only are they context aware from the broader IT estate, so we're looking at how we ingest data from things like Sentinel Lake, which we've worked very closely with Microsoft on, but how do we now apply a much broader set of agents across that, and then how do they themselves orchestrate outcomes in the broader IT environment. So what you're going to see at IBM is we're going to be launching the next generation of our AI approach to cybersecurity in how we now can really orchestrate outcomes across an enterprise environment, as opposed to making security better. We're now looking at how we can make that application across the whole estate much better. And that's, Dave, what we're coining as ambient AI. So that's
I love it. I love
the next phase.
Mark, super informative session. I really appreciate it. So RSA is coming up end of this month, the week of the 23rd, I believe, in San Francisco. So we'll see you there.
Thanks so much
for coming to theCUBE. Appreciate it. And thank you for watching. This is Dave Vellante for John Furrier. We'll be right back at MWC in Barcelona right after this short break.